welcome everybody to today's reusing MEP systems in construction session. Just a quick few intro slides from myself. A big thank you again to Reuse Now campaign sponsors, Cleveland Steel and Tubes, Optima, EME and Reusefully. So the agenda today, once I've gone through my couple of slides quickly, I'll be handing over to James Campbell from Troop by Waters and Anders, that's representing CIBSE this afternoon, and then Kiru from Max Fordham, Nick from Victaulic, Olaf from Valstar Simonis, and finally Paul from Ecoduct, giving a mix of sort of where the industry is at and also some case study examples. Then we should have about half an hour Q&A at the end of the event. So just a real quick overview on the Reuse Now campaign. We kind of kicked it off just over a year ago now with the Reuse Summit last October, working across the industry, obviously particularly with our members, but across the broader industry as well, to encourage the greater reuse of building materials and accelerate the transition to a more resource efficient, low carbon circular economy. We're doing this through deep dives, various different events in social media, case studies, guidance documents. So we've got a lot of information already up on our Reuse Now website. I'd encourage you to have a look at that. More broadly, the ASBP is a not-for-profit mission-led sustainability organisation with the mission to accelerate the transformation to a healthy, low-carbon built environment by championing the use of demonstrably sustainable building products. So whilst today it's focusing on reuse, we are a bit of a broader church, looking at the elements of sustainability, including health and well-being, whole life carbon, ethics and transparency, technical performance, and also social value. Again, lots of information on our website. I say this all the time, that before I started working for the organisation, they were kind of on my radar, but I just didn't realise the depth of information that was available in the research projects that ASBP got involved with. I'd really encourage you to as I say, have a look at the website if you're interested in any of these areas, plastics, paints and finishes, natural fibre insulation. As I say, lots around the reuse of materials. And we've also got the ASBP awards coming up again next year. Events-wise, we've got an in-person event in Bristol from demolition to deconstruction next Thursday on the 10th of October, which is focusing on how we can better utilise the skills and knowledge in the demolition sector to push us forward to be adopting more of a deconstruction approach. We've got Natural Fibre Insulation Week. We've got the Disrupt closing event, that's Disrupt 2, which will be presenting on the findings of that research, which is really interesting, the case studies that we've got involved with there. And then Regenerative Twin webinar again on the 24th of October, and the in-person Reuse Summit on the 14th of November. If you want to find out more about any of those, again, have a look at the website. Just some housekeeping. So throughout the webinar, you can add questions to the Q&A. Please don't do that in the chat. We won't be monitoring the chat for questions. You can upvote and comment on other people's questions. Please don't use the raise hand option, because again, we're not monitoring that. We will unmute the audio if you want to ask questions yourself. Otherwise, we can ask it on your behalf. Have any technical problems, then drop a note to Larry. And as you probably noticed, we are recording the webinar. So if you don't want your audio to come on, then just send your question anonymously, and we can ask it on your behalf. So with that, I will now just do a quick poll, actually, if Larry can pop the first poll up, just to get a bit of a feel as to where the attendees are at with the reuse of MEP systems. If you could just quickly click the relevant one, that would be really interesting to know. Just give it a minute or so. Are those coming through, Larry?
They are.
Fab.
Got most of them in, so we can.
Yep, that's fine. Close that off then. Okay, super. So we have got a few people that have done some reuse, so that's great. Hopefully we'll be able to get a bit more knowledge from the Q&A from some of those examples as well. Thank you very much. So I'll hand over now to James, who's representing CIBSE, to give a little bit of an overview from a CIBSE perspective on the reuse of reuse generally and the reuse of MEP. Thanks, James.
Thanks, Debbie. Good afternoon, and many thanks to Debbie and Larry for inviting me today and the opportunity to give a quick overview of CIBSE and some of our experience. My name's James Campbell. I'm partner of TB&A and head up our strategic asset and facilities management services. And I'm also the secretary of the CIBSE Facilities Management Special Interest Group. For those that don't know much about CIBSE, quick overview: we're a global force for good. We equip individuals to succeed by providing world-class knowledge, resources, opportunities to network and sharing best practice, providing expert, professional and personal support, and hopefully limitless energy and optimism for the future of our vital profession and the building services industry. We look outwards. We're a global organisation with an ambitious and considered worldview, a framework of ideas and beliefs around the built environment through which it interprets the world and interacts with it. We champion collaboration. We believe that the challenges that we face are best met together, and we seek out opportunities to share our knowledge and skills in pursuit of solutions in the drive to make the world a better place. We have a number of societies illustrated there, and we have a number of ever-increasing special interest groups covering a wide range of disciplines and specialisms. These groups create guidance, technical documents, and provide peer review. You don't need to be a CIBSE member to join the group, so I'd encourage anyone and everyone to join one that's relevant and of interest to them. So instrumental in driving towards excellence, and membership provides a route to professional registration and access to training, information and educational needs to keep members current post-qualification in the fast moving and challenging landscape. We promote the achievements and aspirations of building services engineers to the wider world to ensure they receive the recognition they deserve and to attract the brightest and best young talent to join our profession. And membership provides the opportunity to gain professional registration with the Engineering Council through a number of routes, academic and experience. So there's a membership grade and routes of professional registration for everyone. And these are the levels that are available. And there's a lot of information on the CIBSE website and support through CIBSE HQ through people's professional development and membership groups. We're recognised throughout the world as a leader in building services, and our guidance and standards are used and referenced in over 192 countries. So onto something more relevant. Our president this year is Fiona Cousins, and Fiona's presidential theme is Building Performance Reimagined. And she's led the production of a document of the same name and freely available to illustrate Fiona's thinking and to help us push us all to imagining, anticipating and actively shaping the best future we can. So just give a quick overview of some of the elements that are pertinent to today's discussion from Fiona's report. So as building services engineers, we concern ourselves with the building performance every day, but we always agree and understand what it is that we're aiming for and what we value. So the report draws on future methodologies and research to help us imagine what may come next. And whilst we can't predict the future, we can be reasonably certain that we will continue to expect our buildings to do more for us whilst using less resources. So throughout the research, the words health and resilience were used kind of interchangeably by contributors when describing important value drivers and needs. And 4 core performance metrics from the natural world were selected to explore a fundamentally different approach to service design and delivery. And these are variety, readiness, connectedness, and emergence. And I think the topic of emergence is extremely relevant today. So the report thinks about the emergence of new materials, uses, and ideas from what already exists. So learning and adapting throughout the life cycles, healthy and resilient ecosystems, generate, restore, and regenerate, and unlocking local abundance and balancing supply and demand, and fundamentally asking the question, how might building services contribute more than they consume? And the research relating to emergence took some fascinating paths, thinking including a comment from Joshua Dawson of Climate Futures Artists that how about no more construction for the next 10 years, no more construction perhaps for the next 20 years, take what we have right now and adapt it to suit our needs, and we may surprise ourselves. And resources and materials are the key factors pushing and pulling towards circular economies and regenerative design practices against the backdrop of ageing and outdated infrastructure. And in many markets, hotly contested resources and skill shortages in most industries, and perhaps performance may become based on a building's contribution and its users' ability to generate rather than its consumption or emissions. So what are we doing at CIBSE to lead on this change? Well, we produce a wide range of technical guidance to drive industry standards. Technical Memorandum 65 provides a suite of guidance for the calculation of embodied carbon, and not just in the UK, but there's specific memorandums for other countries, including Australia and New Zealand, as well as separate guidance for residential services. And TM65 assessment method is referenced now in the new UK net zero carbon building standards launched last month, and which CIBSE was a key stakeholder in developing. We provide a range of guidance. This currently goes from A to S. Guide L specifically is on sustainability, covering the wide topic of sustainability, but provides specific guidance on circular economy. The guidance references the planetary boundaries and recognises that resource use as a critical issue in respecting these. And more broadly, the guide covers resource efficiency, circular economy approach, principles for building services in a circular economy, the importance of designing out building services and reducing embodied carbon, principles for material selection and product selection, responsible sourcing of materials with low in-use impact and low embodied impact. And it covers embodied carbon and energy, reuse, recycled content, and reuse and end of life. And the document also provides guidance on the assessment methods and tools that are available, as well as sources of further reading and reference. Our Society of Light and Lighting have really led on circular economy recently and developed a technical memorandum, TM66, specific to the lighting industry. And the TM brings together the extent of current knowledge across the industry and provides a framework for action and assessment for all within the lighting industry. And within it includes a couple of case studies to demonstrate how circular economy can change the way we think and what we can really achieve. So I've just picked out a couple of these. The first picture here is of a Whitecroft luminaire that was developed from existing luminaires in a client's headquarters. The project objectives to improve lighting efficiency and reuse as much material as possible. And part of this was also to ensure all works were completed as locally as possible. So Whitecroft utilised a factory less than 40 miles away from the building to undertake the research and development required to build the retrofit new fitting. And the project benefits included over a 2 tonne saving of raw materials, packaging saving of 1.5 tonne, energy reduction of over 65%, and a capital cost saving of 30% per luminaire, which I think is quite relevant in certainly from what we see from an FM perspective, where costs are a key driver. Second image is of Azuntabel's bespoke coal wing luminaire. So the primary project objectives here were to improve efficiency, lamp life, whilst retaining the unique bespoke purpose design luminaire. So the project remanufactured the existing luminaire and was required to submit the redesigned fitting to a UCAS approved lighting laboratory to carry out absolute photometry testing in order to develop repurposed luminaire data sheets and modelling files. And the refurbishment kits were on average 60% lower in cost than replicating and manufacturing new luminaires. And the third image is of a project in Leeds that was suffering from frequent failures and rising costs of maintenance. So a project was set up based on 4 key circular lighting objectives of a cycle of materials where luminaires could be up or down cycled to be reused and recycled and returned to the materials reservoir. An adaptable system allowing lighting to be flexible in the event of change or of use or layout, and flexibility of site systems to have high resilience, allowing for different output changing controls, and ultimately a high quality design to ensure the longevity of the installation. And the project realised a number of benefits, including over 225 metres of aluminium with a total weight of 478 kilograms saved from being recycled, so saving 4.8 metric tonnes of CO2 that would have been released if producing new extrusions. Further 176 kilograms of CO2 saved on transport emissions because less materials requiring less shipment. 55% reduction on energy use and a reduction in capital cost by specifying cassette replacements rather than full fixtures. We also see examples of reuse across other areas of the sector, particularly around controls and BMS. BMS controllers are a regular issue with technological advances that are reducing life of components now, and most providers recommending replacement with new products rather than offering service replacements and other options. However, certain new controllers are not always backward compatible with existing networks, so you end up having to replace a large part of the system when only a very small element was actually the problem. So we embarked on a project to find companies that could repair controllers rather than replace. And for one particular controller that controls fan call units, we were able to work with a company that could repair the controller for £90, whereas replacement would have required replacing all the fan call unit controllers and local networks on that floor at a cost of over £90,000 in that particular project instance. And we're also able to work with another client with a larger portfolio, and this is where I think we see reuse and circular economy being a lot more feasible at the moment when we have the scale to share materials. And we undertook a phase replacement of a BMS in one building so that we could repair and reuse those controllers across the rest of the portfolio and extending the life of those systems. And we're also working with service providers to address some of the skill shortage within the industry and train engineers to replace components such as pump bearings and impellers in order to extend the life of pumps and motors rather than replacing on failure has been the case for many years due to the reduced skill set within the industry. And just on some of the challenges that we face, particularly in the facilities management kind of sector, that cause a bit of a barrier to reuse. As I mentioned, the skill set, we have a large gap in skills in the FM sector, so that's driven a replace rather than repair mentality, because we don't have the skills to repair. Ultimately, in FM, it's generally a reactive approach to issues, and life cycle planning, or planning for life cycle, isn't in place. So we end up with a reactive approach, last minute fixes, clients, shouting and screaming just to get things working, which ultimately ends up in new materials being used. Compared to the design sector, the FM, we definitely lack the collaboration across the FM industry to promote reuse and sharing of materials, very much only focusing on the problem in hand and the building that we're working in, rather than perhaps more widely across the sector. And we generally find excuses are that it's quicker to install new than repair or reuse existing, or that providers won't provide warranties, which I don't think is such an issue if we have the skills to manage and maintain those components anyway. Cost has always been an issue in FM, and as it's seen as an overhead. And as I mentioned, really need to start thinking about whole life when making decisions, rather than the immediate needs. And then the last couple of slides here, very briefly, some of the events that CIBSE puts on this year. One of our biggest events is the Build to Perform conference at Excel in November, and this year we have a section within the conference that we've called Maintain to Perform. So starting to acknowledge the importance of maintenance and operations in relation to building performance. And Fiona is running a conference on the 8th of October in relation to her Building Performance Reimagined report, and a couple of other dates there to look out for. That is it for me. So thank you very much.
Thanks very much, James. It would be really great actually to get hold of those case studies. Some really interesting statistics in there, because a part of what we're trying to do with the Reuse Now campaign overall is not just generate our own case studies, but signpost to and collate what other great work other people are doing as well. So yeah, that would be great if we could have those.
Absolutely. Okay.
We're just going to save the questions till the end. I can see one's popped up there. You might want to respond to that directly, James, or we can leave it till the end. So if we move on now to Kiru at Max Fordham, thank you.
Thank you. Hi, everybody. Can everybody see my screen? Yes.
We can.
Okay, great. Thank you.
Thanks.
Afternoon, all. I'm Kiru Balson. I'm from Max Fordham. I lead the embodied carbon and circular economy work we do within the practice. And today I'm here to talk specifically about a project called the Rylands building in Manchester. Just to give a brief intro to the practice, founded in '66, and we have 5 offices, and it's quite a small practice for the weight of the projects we've been doing. We're just over 200 people, but the core of the practice has always been around environmental design and sustainability at the heart of every decision that gets made. So the predominant work we do is around building services, but we also do other things that will support towards delivering better performing buildings, passive house, embodied carbon assessments, environmental studies, light and air, specific CFD modeling, whole bunch of things with an ultimate aim to deliver sustainable schemes. And the sectors are quite varied, from arts and cultural building right through residential buildings, community projects, both internationally and locally. And also we work very closely with Article 25 on a number of projects where we could take our environmental design experience and collaborate with others. So Rylands building in Manchester, it's an interesting building, Greater listed, and has always been designed to be a retail building with some office use, built in the 30s, early 30s, and it comes with its own challenges of age and also how well it's looked after. So it was very good to hear from James about the challenges of FM and what seen as an overhead cost. So the building is, it came into the practice ready for refurbishment. It's quite predominant in its terms of where it is in the Market Street in Manchester, near Piccadilly Gardens. So the building, the Debenhams occupied this building up until 2021. And all of the floors except the lower 4 floors look like this. And it has been that way for well over 60 years because it's a warehouse building, very deep planned, and the slabs are like 400 mil plus thick in places. And it's a steel frame building encased in concrete frame, curtail windows, just over 380 of them. It's got a story to tell, the building itself. So from net zero carbon perspective, we looked at what could we bring to the table to enable a holistic thinking that looks at both carbon and also the fact that the building is going to be refurbished, which means a lot of material is going to come out of the building. So the target was 600. We are talking 4.5 years ago when we started working on the concept. These targets were set. 600 kilograms of CO2 per square meter and 95% waste diversion from landfill, which is pretty common now. And the innocent target, I call it, the last one, which came from the LETI, where if you want to aim for towards a 2030 position, you need to be looking at reusing 30% of the stripped out material coming out of the building. I do a very early giveaway. We didn't hit that target, but what we did learn in the process of trying to get there quite a lot of things that is helping us to understand what is actually possible and where we need to push more. So the project, I'll go into each one of these in detail in subsequent slides, but the key messages are, the first thing is about what do we do about electronic waste coming out of the building, and that meant we need to understand what when the tenant left, we got the possession of the building to see what we can recover from the building. So just under a ton of electronic waste was diverted, and that included a range of components. The second thing is the big sort of reuse is around 2 generators up on level 7. Each one of them, one was 4, another one was 3-ton generators. Both were craned down and reused elsewhere, but more importantly, it's to enable reuse of engines being refurbished elsewhere. So these engines can support the refurbishment again of other engines. The lights, the over 500 odd lights, but we managed to sort them through and recover just over 550 lights. And all of them are now being remanufactured for various uses across different projects. And we did a TM65 study, and we do know it's 75% lower upfront carbon compared to procuring equivalent same product that's currently available in the market. The core thing here for us in this whole project is not only to reduce waste, not only to reduce carbon, how could we support the supply chain. Socioeconomic benefits was key part of the strategy. Working with the startup and enabling them, giving them the stock they need to start the business was key part of this lighting reuse story. The escalators, there were 9 escalators in the building, so just over 12 tons of steel parts from the escalator was recovered. But essentially, again, it is about supporting existing skill sets and businesses who repair and refurbish components for escalators and lifts. That was key part of the strategy. Alongside the MEP, there were a whole bunch of architectural reuse also happened. That included bricks, and where we could recover bricks, it's all palleted and stored in the building at the moment. That will go back into the building. And also a range of architecturally interesting feature elements that will also go back into the same project for future tenant fit outs. So there's some images to tell the story. It was a challenging concept, but the contractor was on board and the brief was there back from 2020. So the client was on board, the contractor was on board. It's a question of how do we logistically actually make this thing happen, which meant you have to work with the local authorities, highways, a whole bunch of CDM regulations to get those 2 generators off the roof and enable reuse. It's not straightforward. It was a long-winded process, but the commitment was there and therefore it was possible. The lights, the same story, the cost of deconstruction and packaging and transport, who's going to bear those costs? Who's getting those benefits? It's a very difficult one. When it comes to carbon, although these lights are 75% lower carbon when remanufactured, for the Rylands building story, carbon story, this won't form part of the reduction in the overall carbon at all. The benefits lie with the wider industry. If another project, for example, some of the lights went into another art school in London at the moment, and those projects can then claim reductions in their carbon, upfront carbon, because they specified reused lights. The point I'm making here is that enabling of reuse and not having the carbon credit didn't stop us from enabling this to happen. How many projects successfully managed to do this is still a challenge, because finding that storage space, finding that end user, it is part of the problem, but I think there are things changing. FIS got a storage space now, so hopefully things will happen more. So these lights are now available and our engineers are specifying them in projects. That's the beauty of circular economy, where you're actually not just talking about what we recovered, actually how is it feeding the wider system and therefore benefiting the whole system rather than just one project. So I learned a lot about escalators, never seen underneath an escalator. It was amazing to know about parts, what it does and everything else, and find the contractor who could potentially take this. So yeah, some images. But thing is, it's not all rosy. There were many things we tried and would have liked to have done more, but some things just disappeared, like cable trays. They were all labeled, palletized, secured, but in the process of construction, the admin costs involved in supervising reuse is so great that it's still a challenge. I think it falls through if the contractor team doesn't appoint a dedicated person during construction and track this on day in, day out basis. It's difficult to track materials, especially in refurb projects. And I think that's the last slide. That's me.
Thanks, Kiru. Yeah, I think what you're saying about the difference in carbon credits between the project that's donating the materials versus the project that's reusing the materials, I think that's quite a challenge, because as you say, there are clients and project teams that are passionate enough to drive it through regardless, but for that kind of middle group of people to try and push it closer to mainstream, where they're kind of like, yeah, that's quite a good idea, but there's not quite enough benefits yet for us to maybe look at that. That might be the extra push for them, where they'd get those carbon credits.
Yeah, I think what we are doing, it's key part of our strategy within the practice now, reuse, because we are working with both internally with the services engineers and also the architects, is about supply chain engagement. It's intention is there for everybody, but it's the practicality of seeing it through and converting it into reuse is the challenge. Yeah, so every project we are working on, we are aligning more close with manufacturers rather than sort of like trying to fit in things. If it's not
Trying to
possible,
find a recipient.
yeah, it's absolutely key. But not all manufacturers, particularly within the services sector, is there yet. But some are here, so hopefully we will see a change.
Yeah, I think it is quite a big pivot for people's business models, and if I don't think it's not just about not getting it, though there is an element of that, but I think some can pivot a little bit more easily than others without feeling they're cannibalizing their own income streams, because that's the difficult
Absolutely.
part.
Yeah, it's a commercial model. At the end of the day, it costs money to do reuse.
Mm.
So how do you do it efficiently? And if there is demand, there will be supply.
Yeah,
So,
yeah. It's we say getting it to mainstream and getting those economies of scale, but with lots more examples, which is really good, and obviously a big part of what today's about, showing that art of the possible. Brilliant. Thank you very much for that, Kiru. So if we move on now to Nick at Victaulic, please.
Can everyone see the screen?
Yeah, thanks, Nick.
Awesome. Well, let's get underway. Good afternoon, everyone. My name is Nick Vandenbroek, and I'm the Business Development Manager for the UK for Victaulic. And so with us being more of a manufacturer piping design company, there's people in the room that might not exactly know what we do. So as a bit of a quick overview, we are a 100-year-old company delivering sustainable piping solutions for the global construction market, essentially. And with that, I kind of wanted to just iterate a little bit on the actual. Oh, how do you change slide? How do you go to the next slide?
Just try page down or right click.
Just down the down arrow key. Normally.
Yes. Not doing anything. Shut up screen. Let me try one more time.
Classic scenario of it working when we tested it,
Mhm.
but not now. Not gone onto full screen yet.
Yep. Oh, here we go. Perfect.
Yep. Brilliant.
Yeah, sorry. So I just wanted to kind of give a bit of an overview of the kind of history, because I think that emulates really well and parallels what we're kind of trying to do now with the sustainability front, but more so on the reusability. So just as a quick overview, the company was founded back in 1919, so just on the cusp of World War I, by the two gentlemen you see there on the screen, both from the British Royal Engineers. And essentially it was invented for World War I as an alternative to the traditional method of deploying fuel or fluid throughout a piping system. So typically, at that time, it would have been a weld or a flanged piping system that would have been deployed. So these two gentlemen wanted to think of an idea about how do they build pipework effectively, efficiently, quickly, without all that intensive labor and materials. Where they're in the battlefield, they can't exactly, whip out a welder or bring in more pipework. So they wanted to find a way to basically build pipework easily. And so they came up with the idea of a victory joint. So this victory joint being a coupling, which on the photo on the right-hand side, you can see joining the pipe together, which essentially they groove the pipe, they put the coupling on to join those pipes together, And that pipework or that coupling can be reused. So as the Allied forces progressed, they could add on pipework to that system. As the Allied forces retreated or deviated, they could disassemble that coupling and that pipe and then use it elsewhere. So that concept has kind of been utilized throughout. These are photos now from World War II. Same concept applied. The Allied forces applied these couplings. And the photo on the left is 500 miles of pipework conveying either fuel, so that could be petroleum, diesel, and then also water along the Rhine River. The one on the right-hand side is actually one of the generals, the British Army general, inspecting the coupling, which is deploying fuel from England to France. So in this particular pipeline, there was thousands of miles of pipe using the couplings. And so how the company name now came to be, it was victory from the Allied forces plus hydraulic combined to form Victaulic. So very original. But today, now we are using multiple applications. So I've just given some examples here of projects within the UK, more so kind of London-based, but there's a few other outliers. But residential, commercial, airports. We've got the bottom left photo, Scottish Water, which is drinking water. That's 32-inch diameter pipe. We've got football stadiums, and then on the right-hand side here, we've got, this is Thames Tideway, so tunneling projects. And with that specific photo on the right-hand side, for the temporary services, so for either for water services or air services going into the tunnels or the mines, they use the Victaulic product, which can be assembled, and then once they've finished that project in, say, a year or 2 years' time, the mining or the tunneling companies will disassemble that and then use that on their next projects as well. So in that specific case, on the bottom right-hand photo, once that system there was finished and installed and the project was completed, they disassemble that and then reuse that on the Silvertown tunnel afterwards. Similar cases we've got with HS2, where they moved temporary services from the HS2 to then other areas of the project as well. So I just for the purpose of people that might not know specifically what we're doing, I just wanted to go into a very broad overview. Essentially, Victaulic is a way of joining pipework. So instead of welding or flanging, you put 2 grooves at the end of adjacent pipes. And then with those 2 grooves, you then put a gasket over to seal it, and then you put a housing on top of that, which has nuts and bolts which tighten around that coupling or that gasket. Sorry. So just as a very quick video, just to kind of emulate that a bit more, you have your 2 pipes that are about to be joined together into the coupling, and then you tighten up. So I know it seems very simple and elementary, but this in itself is such a convenient way to join pipe, opposed to welding a system or flanging a system, which then creates a permanent single-use joint. Whereas this situation here, it's reusable. Essentially, the gasket, the coupling, and then the fittings are completely reusable. So I'm not going to play the whole video just for time purposes, but in this case here, I'll just pause it. There's an elbow or a fitting that is also matching up to that coupling, and that fitting has grooves that are built into the actual product itself. So with that, it's completely customizable. And on that note, the best way I like to describe Victaulic is it's like a giant Lego kit, like a giant Meccano kit, where it's completely customizable. You can build up, you can build down, you can swap parts out when need be. So it's quite a reconfigurable solution. So I know everyone's seen this slide before, but I just wanted to kind of go over it from a manufacturer's kind of point of view and how different things are considered. So if we talk about from cradle to gate, or it's typically from A1 to A3, so that's extraction of the raw materials, manufacturing of the actual product itself, and then once it leaves that manufacturer's facility, that is your cradle to gate kind of carbon analysis. Then there's from cradle to grave, which essentially is that same process of manufacturing, then construction, and then however the decommissioning process happens. And then the strongest message, the one that Victaulic is kind of wanting to emphasize and push a bit more, is cradle to cradle. So that's essentially from manufacturing to the install, the use, the decommissioning, and then that reusability of it all. So creating more of a circular economy, and that's where we want to kind of emphasize and push out our message a bit more. So just on the reducing carbon, embodied carbon. So as a comparison, so I'm just going to be comparing just for the next few slides between a typical system and what we've kind of got to offer. A welded fitting, so that's the fitting that has to be, whether it be an elbow or a T for a mechanical or a compressed air system, that has to be made somehow. And typically that's a raw extract. The material's been extracted from some other continent and then processed and transported to a different location to then be melted down. Typically that kind of situation and those technologies that they use are outdated. So they're typically using blast furnaces, which are the most inefficient way of manufacturing or making fittings. And then after that, there's extreme heat that's been applied to physically shape the actual fitting that's it's trying to form. And then from there, there's additional transportation to the actual point of sale. So there's a lot of excessive transportation going from one continent to the next, and then from there to the point of sale. In comparison, Victaulic products are made from 100% recycled scrap steel. We use the latest and the cleanest technologies, so that'd be induction electric furnaces in this case. We reuse all of our casting sand to actually create and mold the fittings. And then we have really advanced technologies and processes and lines to actually make and manufacture the actual fitting itself. And then where all our foundries are positioned, they're all strategically positioned in places closest to our biggest markets. So in the case of Europe, we have our entire facility in Poland, which distributes out towards Europe, and similar situations along North and South America and in Asia as well. And then the big thing with reducing of the embodied carbons from a product perspective is the actual emissions to install the actual product. So comparing again to a traditional setup of welding, there's a large amount of waste, solid waste, whether that be from the rod, the spools, as well as toxins and gases actually produced from the actual fusing of the materials as well. And then with the welded system, it creates a single-use system. So once you weld that spool length, that pipe spool length into place, it can't really be reused because there's so many different dimensions and specifics that go with it. So essentially, if there is a mistake or if there is a clash, that spool piece essentially has to be thrown away. And with that, there's also the generic health and safety risks of welding products, where there's, again, the toxins, you're dealing with naked flames, open fires. So as the comparison, the groove system is a completely clean and cold formed method, so there's no flames that's being used as well. So all of this can be an on-site or an off-site installation, and it's 100% reconfigurable. So it's a permanent joint when it's bolted up, but then it can be unbolted and completely customized to how you need the system to go. So then from that, there's zero emissions, installation emissions. And then just to touch on that infinitely reconfigurable point, the gasket inside the coupling, which seals everything, is reusable as well. So that there means, again, you've got the permanent joint that's 100% adjustable, and it can be used in different locations and different applications as well. So the big thing is some examples that would be associated with this reconfigurability situation. Is an example would be like a shopping mall, where tenancies change constantly in shopping malls. Typically for mechanical and fire protection systems, those tenancies, all the mechanical pipework and the fire protection pipework would typically be stripped out and disposed of in some way. Whereas with our situation here, with using a grooved Victaulic system, all that stuff can be reused and reconfigured to fit into the right spaces. And this is just a pictorial example of how that can happen. It doesn't matter wherever a joint is, that joint can be changed and amended to suit whatever the parameter requirements are. And then the last one, just to touch on with more from an FM building owner perspective, there's no maintenance required for any of the Victaulic products that you see. So typically with a flange system, which is a compression joint, when you take apart that compression joint, you now have to throw out or replace that gasket, that rubber gasket. Whereas from our situation, you don't need to replace that gasket. It can be reused. On top of that as well, if you do break into a system, there is the generic shutdown time that's required, which means the building has to go offline, whether that be some kind of watering system, so drinking waters, potable water, or your heating or cooling systems, that means that there has to be a downtime. Whereas with this now, you don't have to worry about that. It shortens the time. And then the one thing I want to emphasize as well is end of life. So typically at the end of the life of a project, that mechanical system is cut out and disposed of in some way. All that pipe that's been cut out is essentially useless. Whereas with the Victaulic system, it can be deconstructed, disassembled in a much more easy manner as well. And then with that in mind, we do have a recycling program as well, whereby we take back the materials that have been used on that site and we reuse it, and we put that through our recycling process, and then put that back into our smeltering plants to then be cast again into new products. So we've done this on a few instances. As a good example of that is the Paris Olympics, so Paris 2024. We signed an agreement with the stakeholders, the main contractor, and the mechanical contractors to help install the temporary systems which fueled and heated and cooled the different buildings that were created for the Olympics. And then after the completion, we then assisted with the decommissioning and took back all that product to then get put back into our foundries to be smelted and made into new couplings, fittings, and valves. And with that, the gaskets, we've had two instances in the US where the gaskets have been given back to us as part of an agreement, and we've then repurposed those gaskets into different types of astroturfs or playgrounds or athletics tracks. So just to conclude, all of those like pillars, essentially, yeah, 100% recycled steel, which we're then using the clean induction electric furnaces and the streamlined manufacturing processes, and we manufacture close to the markets, as well as there being an infinitely, zero installation emissions created, so there's no welding involved whatsoever, so then no flames. And then because it's reconfigurable, you can repurpose it, you can reuse it, and then right at the end we've got the recycled program, which kind of creates that circular economy, as you would. Yeah, thank you.
Thanks a lot, Nick. One question did pop up on leasing, but I think we'll save that for the Q&A, because I think that would be interesting to ask all of the presenters. So if we move just swiftly on to Olaf at Valstar Simonis to give us a bit of an overview, and then we'll just have a quick couple of slides from Ecoduct and then get on to the Q&A. Thanks very much, Olaf.
Debbie, can you all see my screen?
Yes, we can.
Yes,
Thank you.
thank you. Well, actually, thanks for having me. First time I give a presentation like this in England, or in the UK. My name is Olaf, and let's see if I can switch my screen. Well, yeah. My name is Olaf Oosting. I'm managing director of Valstar Simonis. I guess you all never heard of it. A Dutch MEP consultancy and advice firm. Actually, I'm in The Hague in the Netherlands, and we have 3 other offices in the Netherlands. Since 3 months, we are part of Sweco. I guess most of you know that one, a large Swedish consultancy group. Well, actually, we are at Valstar. We are working together with 70 employees on all kind of building service and installations for the most difficult projects like hospitals, also universities, etc. As a managing director, of course, I'm leading the company, but on the other hand, I'm advising on strategic questions on sustainability and circularity. And Debbie asked me to give some Dutch examples of the way of reusing MEP systems of the Netherlands. It's also good to mention is that I'm also a board member of TVVL, which is the Dutch version of CIBSE. So that was quite a connection, I guess. I don't know much about the UK legislation about circularity, etc. But in the Netherlands, we do have the MPG, which is a sort of environmental performance coefficient. If you want to have a permit to build a new building, an office or housing, we need a calculation of which says something about the environmental impact. And as you can see, well, it's in Dutch, of course, but as you can see, the MEP is about is around 35% of this this calculation, and that's why I'm very happy with this attention for circularity in installations, because we're talking a lot about it, but there's not much happen, and that's what we saw at the poll at the beginning. No one said yes, it's easy. It's quite difficult. And in the Netherlands, the building services are accountable for 35% of the calculations. Why are we talking about circularity? In my opinion, of course, we have the 1.5 degrees in 2050, and everyone is talking about energy and energy efficiency. But this is an article in the Dutch Financial Times, and it says, okay, without raw materials, we cannot make the energy transition happen. And that's why I'm focusing since 9 years on circularity in building services. There's a lot to do, and yeah, a lot to do. Like I said, I'm advising on a strategic level on circularity in building installations, and we focus on 3 different strategies: circular design, circular products, and a circular business model. And well, reuse products is about circular products, but I'm also have some examples from circular design, because like Nick just stated, replaceability, disassembly is also part of reusing, is also necessary to be able to reuse MEP systems. I have some examples. Like I said, this is what you don't want to see. It's waiting for the concrete here, and there's no way of any possibility to reuse the systems like you see here. Once the concrete's in, they're all gone, and you never can reuse them again. So what we're aiming for in our advice, MEP advice, is more modular systems, and Nick also had some examples of it. Like you can see on the picture on the right, it's quite easy to replace if there's anything broken or anything needs to be adjusted, etc. And that's one of the circular design strategies we're using in our advice. You can just make it replaceable, better replaceable. This is an example of, and this is not mine. This is Circle in Amsterdam. I don't know if anyone of you knows it. Yeah, it's a very good example. This one is designed to be disassembled, and actually the expectations of the architect were that it should never happen, and actually it's being replaced now, or it is already replaced. I don't know the exact situation. But this is in our banking district, and like you can see on the right, it's the sprinkler installations. They're all very replaceable and designed for disassembly, so you can easily replace them and use them anywhere else. This is a project also in Amsterdam. It's called a temporary courthouse, and well, like the name already said, it's temporary. The original courthouse was renovated, and they rebuilt the courthouse for just 5 years. And it's replaced in the eastern part of the Netherlands. And the structural things are relatively easy to replace. The former demolition party, which is now a disassembler or reassembler, also mentioned that some of the installations were quite easy to reuse, not all of them, but some installation parts are definitely reused, and a few hundred kilometers more eastward. I also have some examples from Dutch startups who are selling reused projects or refurbished products. On the left, that's also is what we call a former demolition party who's reselling gas-fired boilers. Just one-on-one, they picked them up at some housing corporation, housing. I don't know the English word. You know, the housing corporations, and they picked up the gas-fired boilers and reselling them. But on the right side, there's a party in action who is refurbishing several parts of gas-fired boilers to, you know, to create a stock for older boilers and to keep them in the to extend the lifespan. Also one is well, actually I had to Google this morning. This is what we call staker bar, and it's you know the pluggable cables and wires. I never used the term before, but this is a startup which is taking back pluggable wires and cables. He's testing them, and he's reselling them to installers to be reused just one-on-one. And well, it's quite an interesting proposition in my opinion. This is also a special one. Systemair, it's a Swedish party, but also active in the Netherlands and I guess also in the UK. They took back an air handling unit, and that was quite an acquisition. It was just a pilot for them to see how do we get it back, what can we do with it for the future. So as you can see, the production airflow was around 40,000 cubic meters per hour, and it had a heat recovery with a twin coil. And well, they took it back, they cleaned it, and they had to replace some parts. And afterwards, it's still with guarantees able to create an airflow of 100,000 cubic meters per hour. And the heat recovery is now around 50%, so it's better than it was. And you know, the only thing is you need to like the color or not. But it's 34 years old. In my own practice, I'm working on circular buyer strategies, and this is also for me. I'm able to get my clients to have more circular products, and this is for servicing building services or installations. And I'm how do I say that? I'm trying to get the products that the installer had to take out to get it as how do we say that? To get it as good as possible to get it reused or even better. And for new products, I also want to have the environmental impact as low as possible. So that are two strategies. If things have to be replaced, these are the strategies that I would like to get in the tender to get it as circular as possible. The session is about reusing. I'm also doing some studies on bio-based installation products. A colleague of mine did his master thesis about bio-based air ducts. Very interesting. Main goal is to lower the environmental impact, of course, and that's possible with reuse of products, but also with bio-based products. So I'm very interested in the thoughts you have about it. And at last year we made, and that's of course it's all in Dutch. We made an agenda for the building services industry with 8 different actions to take if to get a more circular building services industry. So that was very quick. Any questions? Maybe later.
Thanks very much, Olaf. I think it would be great to have a translation of your those eight points there. Maybe we can pick up
This one, yeah, of course. I can make that.
Pick that up after the event, and maybe kind of
I will share a link with an English version
with the slides. No, yeah, that'd be really interesting. Thank
Great.
you. Well, we'll hop straight on to Ecoduct, which is Ecoduct for a new brand new ASBP member. So they've just got a little bit of a pitch, couple of slides, and then we'll go straight on to Q&A, because we're already, as tends to happen, already running a few minutes over. So I'll hand over to Paul. Thank you.
Steve and Larry, for the opportunity to present today. Really appreciate it. Yeah, well, Olaf, second last slide referred to air ducts, and that's exactly what Ecoduct is about. So thanks, Olaf, for that. Good timing. So just to give you some perspective, Ecoduct is the only UK fabricator of all shapes and sizes of pre-insulated non-metallic ductwork. So it's air duct, but which basically doesn't have a metal component. Typically, ductwork has got metal surrounded by insulation, and this is fully non-metallic. And there are just some pictures of it. The idea was to create a much lighter ductwork system. It's about 85% lighter than the metal equivalent, but also that had to be very robust, because it was critical that the duct system be robust, which Ecoduct is. And in fact, it's on the first point there, it's the only ductwork that we're aware of, certainly in the UK and in the EU as well, that actually is rated as Class D at 2,500 pascals, which is actually for air leakage, which is absolutely critical in a number of factors in terms of performance, but also in terms of energy costs and wasted energy in terms of leaking air. We also have the only ductwork that offers a product warranty, which actually is 25 years or the life of the mechanical plant, which is unrivaled in the industry. We also, and this is critical in terms of the recovery and the reuse situation, we offer a buyback scheme, both on installation and on end of life. So there's a recovery. So there's a recovery and reuse, and using it with a buyback scheme, and as I said there before, a product warranty. Again, some perspective, the use of Ecoduct can save up to around 75% in terms of embodied carbon, because of the lack of the metal component. And the savings have been up to actually 57% in terms of the operational carbon in the use, obviously in the operation of the HVAC. So it's absolutely really meaningful savings. And as far as I'm aware, there's no other ductwork that can provide these sorts of benefits. And then it has a lot of other sustainable and environmental benefits that you can see on the screen. And also critically, in terms of material safety, it's a completely inert material with no hazardous substances whatsoever, and no significant emissions. So just to focus on reuse, this slide relates to the issues regarding reuse. Because we've got a unique precision razor cutting fabrication process, where we effectively mold the insulation panels into all shapes and sizes, as you saw on the first or the second slide. And our focus in terms of circularity is on recover and reuse. And again, I think we're the only ductwork that I'm aware of, and I'd be interested to actually hear from Kiru about what happened at the Rylands building in terms of the old metal ductwork. But I'm not aware of any situation where metal ductwork has been able to be recovered and reused, because old metal ductwork typically is oxidized, it leaks, is damaged. So I'm sure there are some situations, but I'm not aware of them. But certainly with Ecoduct, it's very easy to deconstruct. And as I said, our focus is on recovery and then reuse without the need to recycle, which surely is the best way to do it. So that's our focus. And if there is some waste but that can't be reused, then we will recycle that. But as I said, our focus is on recovery and reuse, and that happens in 99% of the time. And then just to see just some pictures. This is actually relating to a specific project. So you can see on the left, the two pictures on the left, the Ecoduct installed. And then we, on a project where they had to change the configuration internally, we recovered the ductwork, and that's actually a photograph from our factory, and anyone's welcome to visit and have a look. But that's a photograph of the ductwork that was recovered, and then will be reused on a further project. And then the equivalent on the right there, the metal plus insulation, you can see that's not only metal plus insulation plus a wire mesh to try and keep the insulation in place. And then on a different project, but there's the ductwork that's been taken down. And certainly you wouldn't be able to reuse the insulation. I mean, that is fairly obvious from the picture. And it tends to be difficult to reuse the metal ductwork. And if it's going to be recycled, then it's going to go right back into the high energy recycling process, which pretty much defeats a lot of the object. And so that's really the comparison between the two. And we are proud of what we can offer, and we believe that we're optimizing circularity. And as I said before, and that optimizing circularity comes from a focus on recover and reuse. Hence my thanks for being able to participate today, Debbie.
Thanks a lot, Paul. Some of the questions I can see have been answered, which is great. Thanks very much, panel. I think there's a couple of questions, and then kind of those questions have been built on around leasing. And I know when I mentioned it to Kath earlier on this morning about, you know, what kind of questions could we ask, that definitely came up as well. So I think, you know, obviously a key part of circularity on the reuse piece to ensure you get the materials back for reuse, or worst case, at least closed loop recycling, is to offer leasing. I think if we go to Nick particularly, I think Tom, I don't know if you want to come off mic and ask about, particularly on temporary works. Did you want to ask a question?
Yeah, well, otherwise I was just gonna, yeah, all those three questions are very much interlinked, let's say. So just the first one, I just see one of the questions there. In terms of the pipe work itself, the physical pipe, that is not supplied by us. We are compatible with all types of pipe, whether that be carbon steel of any type, stainless steel or copper. So the pipe work specifically, we wouldn't look at. However, the couplings and the fittings, as an example, those are obviously that's our stuff. And so in terms of so just as some references, with the example of the Thames Tideway and all the tunneling projects we've got going on here, that contractor would buy the product outright. And then what they would do is then they would, once they finish one project, they would use that same material, potentially changing the gaskets out if they're changing to a different application, and then they'd reuse that. We would then come in and provide a service where we inspect all those couplings that have been installed on the second project, and go from there. In terms of the example of the Paris Olympics project, I believe in that case, again, the client bought out the materials outright, with the idea of we had a roundtable discussion with the stakeholders, and they were unsure what to do with that temporary pipe work. So we said that we would take them back. And on that note, in terms of the commercial model, when we initially sell that product, there would be some kind of thing built into that sales structure, that commercial model, where we would propose some kind of compensation at the start of the project, not so much at the end when we take it back. But what we would typically do, we would take back the material and then recycle it if we're going to be doing it that way. Otherwise, if the client wants to continue, or the contractor wants to use that product on another job, we can, depending on, so the warranties are a bit of a tricky one when it comes to warranties, but with the warranty, if it was a temporary project, for example, and using the Paris Olympics as an example, that material, if it was installed within 1 to 2 years and they wanted to reuse that on another project, then yes, we would look into offering a warranty for that next project. And we'd also do a certificate to say that we've inspected it after it's installed to make sure it's been done correctly. Whereas if it's a project, let's use the other extreme, that's been installed for 30 years. With that, as long as there's no issues, there's no leaks, you could use it. We would recommend replacing the gasket, just because for that time frame it's quite, I wouldn't recommend it. But then we would also provide a certificate to say that we've inspected it, but we more than likely wouldn't offer a warranty on that length, because it served its purpose for that time frame. So hopefully I've answered some of those questions.
Yeah, I think so. There was a cradle to cradle certification part of one of the questions as well,
Let's see, certificate mentioned.
because you mentioned cradle to cradle.
Yes. So at this stage, I'm actually not 100% sure on terms of the cradle to cradle certification. We have a sustainability team at the moment that are just about to release our EPD values for all the different product ranges that we've got. And so I'll have to find out more. Is it Si? And send it over to you.
Yeah, super, thank you. I think another question that's quite interesting around the fact that obviously MEP covers a large number of different products. I don't know, Kiru or perhaps James, you could kick off with if you were prioritizing what going in sort of pre-demolition audit stage, looking at a whole building and thinking of which areas of MEP could you particularly focus on, what you'd recommend for those to be, or is it literally a building by building, case by case basis? Maybe start, Kiru, if you're happy to take that first.
Yeah, I think it is case by case, really. It depends on the condition of the equipment and what is the future. What's the building going to do? Is it just an upkeep maintenance job, or is it a retrofit job, or is it a full deep refurbishment job, or is it a demolition where everything must go? So depending on where a project is in that scale, each kit can be either repaired, refurbished, or taken back. But it seems to vary. Like lighting is, because it's modular, there is the push to enable manufacturing. But when it comes to things like cable trays, clip-on cable trays, and getting it re-warranted and certified, and also even to deconstruct and palletize and shift it between sites, it's a logistical challenge, although it's just a passive kit carrying stuff. So I think there are some easy wins one should do, like lights, do them. There's no, and also if you're specifying, why not specify remanufactured lights? It's not just about what comes out of the building, it's what's going into the building.
Yeah, absolutely.
So lean design is absolutely key. Less or no ductwork is better than large ductwork that is going to come out at some point. So it's about better design and finding out what is proposed for that particular instance. Case by case, item by item, actually, in case of MEP, it's not a generic conversation. It's always very specific.
Thank you.
I don't know, James, what's your...
Yeah, I think I'd agree, and it is on a case by case basis. I think it's difficult with MEP systems in that generally, if we're looking at a refurbishment or a new build, for example, or an existing build, then we're looking at systems that are 25, 30 years plus, and the technology is advanced, and we wouldn't be reusing that technology in a modern building because we could be more efficient, and actually the operational carbon impact of reusing something that's quite inefficient outweighs the embodied carbon, and hence my comment about considering whole life when we're making decisions. We need to weigh up the operational impacts as well as that of the construction stage. I think where reuse of existing systems can work is when they're used to support the extending the life of existing other buildings and systems, and I think this is where we need to come together as an industry. Is how do we share that knowledge that we've got a chiller that's 15 years old in this building, it's still operational, it's still suitable, it's not the right solution for this building going forwards, but that doesn't mean that we need to put that in the bin. Someone can make good use of it somewhere, but how do we connect that bit of plant to the person that needs it?
Yeah. No, I think as with all of the kind of circular solutions, it's making the most of what we already have in our existing buildings, whilst thinking about the challenges of trying to reuse and deconstruct, and letting that inform the way we're designing new systems and new buildings. So I don't know, obviously, James, you did mention some guidance that was coming from CIBSE. I don't know if any of the panelists want to comment particularly about what other additional guidance there should be for designing for reuse.
It's always good to start, you know, like in my practice, we're always designing for that specific project, you know, and it's always different from the building next to it, etc. You know, it's always a unique design, and that's good for our rates and for our workload, but it's not so good for the circularity, for the circular perspective. So actually, we should build more standard installations, in my opinion. It should make it easier to reuse parts somewhere else if necessary.
I think the standardization piece,
Yeah.
again, that flows through all of it really. Standard grid, standard lengths, yeah, and customization piece being more subtle than I guess some of the buildings that we've got that are customized to within an inch of their lives. So are there any other questions we've got? Salvo, one of the main challenges I face when reusing MEP systems in new construction projects is receiving a lot of pushback, mainly because reused MEP systems typically come without a warranty. How can we overcome this issue? And again, across the board, not just an issue with MEP on that, with the warranty. Don't know any of the manufacturers. We did obviously talk about lighting, remanufacturing of lighting. I think that being done more now, and there are warranties coming through for that. I don't know if there's any other areas of MEP where the panel are seeing warranties being offered.
I mean, from a ductwork point of view, we'll only offer ductwork for reuse where we're prepared to back up with a warranty. So our standard warranty would apply for new or reuse, because we wouldn't release a duct for reuse without it being in good condition.
Fit for purpose, yeah.
Mm.
Thank you.
Yeah, I feel from our perspective, I think I mentioned it before, with when products has been installed for a smaller period of time, so 1, 2, potentially 3 years, we would definitely look at, if that product is to be reused somewhere else, we would look at offering additional warranty on the new install. But when it gets to, I think it was James or Olaf mentioned before about a project that's been gone for 30-year install, it's a bit challenging in that aspect to offer a product warranty for something that long, where there's so many uncertainties that could have gone on with that.
In our experience, lifts and escalator sector, that's actually a hidden sector. A lot of things get repaired, and like Entopia building, I think that I was not part of it, but what I found out afterwards was the Max Fordham team had to work with the subcontractors actually doing the work to see. The original plan was to take out the lifts, but then when they worked out it's actually possible to repair, we can get warranty, because the university wouldn't accept anything without the warranty. So anything and everything that gets refurbished in an existing building, in that scenario, we managed to get the warranty not from the manufacturer but from the installer, who was repairing the lifts. And also, it's when it comes to reuse, it's not always about getting something from somewhere else and getting the warranty for it. Most of the time, it's about getting warranty for what's in the building if you're repairing, and to retain it in the same building. And we're starting to see that in, like James talking about BMS controllers and the age. It depends on the age and the software systems and the compatibility, but you can do bits and pieces around controls in general and pumps. And there are take back schemes for pumps now as well. So it's definitely the inventory list for MEP is significantly greater than architectural elements. And this is why manufacturers in the MEP sector need to engage with warranting and reuse. Designers alone can't enable this. Everything is bespoke, like Olaf said, like from ductwork sizing to pipework sizing. It's really tricky. You can't take a ductwork from building A and put it in building B. It depends on what flow rate you're designing to and what performance and design efficiency you're trying to achieve. So
I think that, Kiru, a lot of this needs to be driven by the client ultimately to make the end decision, and they can only do that if they're informed and understand the risks. For a contractor to say, "I won't warranty that pipe work," doesn't really mean anything unless we understand what the risks associated with that pipe work is. Because ultimately, if the water quality's been well maintained, that pipe work's in good condition. I very rarely see pipe work fail because of the pipe itself. It is generally down to an installation defect or workmanship defect, and we should always have warranties on workmanship regardless. So the excuse of we can't use that pipe because we won't provide a warranty is fine. We'll take that risk, but you still got warranty your workmanship. Because that's probably where the highest risk actually lies.
Yeah.
If clients understand that, then I think they'd be more open to reuse.
Yeah.
One ticking time bomb, I think, just this one point, because it's currently sort of like bugging me. Like lighting, I think another sort of ticking thing in the background we all have to grapple with is PVs. So all the PVs installed in the mid-90s, early 2000s, and more going in now, closed loop recycling in the UK. I think if ASBP could do something around that, even if it is industry engagement to get people to talk about it, would be really helpful. It's a modular system. I don't know if there are any plans, but
I think I've just seen an event. I'll send it your way, Kiru, on solar circular economy challenge by the NICE Centre. So I think they're doing something. I was going to ask a question on M&E consultants, and is it easier for them to design new rather than use something that's already in place and having to sort of retrofit to it? But I'm going to get told off by Debbie because I think we're nearly out of time.
definitely harder to design with what you've got because it depends on what it's going to do and what operational efficiency you're trying to get.
There's a cultural thing there. It's just easier to start new sometimes, isn't it?
Yeah, I think it's also technical challenges around it, isn't it? And a piece of wire carrying so much electricity and the wear, and like how do you test to ensure that the wire quality encased within plastic is going to carry on doing what it's designed to do.
It can last for years, normally.
It depends on the connections
Of
and
course,
how
of
it's
course.
transit. It's just like once you start getting into it, would love to learn to reuse wires to start. There's so much copper in it, but yet the minute you start talking about it, it's not just the risk averse attitude, it's also the performance that you're trying to design to. I think it's a combination of the two. That's just what I think. I don't know what others think.
We just need to draw it to a close there. I think we do just have one other quick poll if Larry can pop that up before we all leave. He has also put a feedback form in the webinar chat. We'd very much appreciate it if people can quickly fill that out. It only takes a couple of minutes. So the question, what needs to happen to ensure more reuse of MEP? Again, this will just sort of inform future ASBP work around this. And it's interesting with Kiru there saying particularly to maybe pick up on solar panels as a subject area we could look at moving forward. Yeah, policy, definitely, Tom. Yeah.
Campaign for discounts. You don't have to pay VAT. Trust me, the minute there is money saving, everyone will be doing reuse.
Well, that's the ridiculous thing between the difference between new build and refurbishments anyway, isn't it? That just feels like a bit of a low-hanging fruit decision, but it still doesn't seem to be any quicker to be being made, but we'll see. Are we pretty good with numbers on that, Larry? What most people answering?
More.
We are just a couple of minutes over now, so I will just say thank you ever so much again to our panelists. That's been really interesting today, and sort of to kick off on what I think is going to be a longer term look at the reuse of MEP systems from an ASBP focus perspective. So keep an eye out for other work we'll be doing on that. And yeah, get in touch if there's any specific areas, as Kiru's mentioned, on the PVs that are of interest, or work that you're already doing that we can maybe dovetail into, because we are huge fans of not reinventing the wheel, and we would far rather work with somebody else on something that they're already doing rather than start something afresh. So if you want to close that poll, Larry, please. Yeah, more guidance showing the quick wins. Yeah, which is difficult, as we've said, because each building is different. But I think yeah, there's quite a lot out there on the lighting, I think, particularly. So maybe we can signpost a bit more to what's already happening there, and then explore other products and systems as well. Okay, well, I think we'll finish there. Thank you ever so much again to the panelists and everybody that's still hanging on in there to listen to the end from the attendees. Please get in touch to find out more about what the ASBP are doing, and hopefully we'll see you at another event soon. Thank you very much.
Thank you.